know? Oh, there we go.
It gave you like a millisecond countdown.
It did. Yeah, that's working now, right? That's my pause button. All right. Okay, we're killing this. So we are finally ready to actually learn some math. We learned lots about injuries. That's about it. Today, we're going to start solving systems of equations using algebra. Okay, that means like by hand, like messing things around. On all of our previous tests, we haven't had written response, right? It's always been multiple choice numeric response. This test is going to have written response on it. The reason being is we need to see the process that's algebraically done. There's going to be two processes that we learn. Processes. The first one's substitution. That's today. Tomorrow's is elimination. And you will have to demonstrate both of those strategies on an exam. Okay. Remember, what we're doing in this unit is figuring out where two lines cross each other. Okay, that's the whole unit. You have two lines, figure out where they cross. Before today, we always did a graph. It was pretty easy. If you could graph it by hand, it was wonderful. If you could graph it with your calculator, even more wonderful, because then you could figure out decimal answers and all that jazz. If you didn't have a graphing calculator, or you had a question that you couldn't graph, which definitely happens next year, you have questions you can't graph, then you need to use one of these two following methods, substitution or elimination. They do have step-by-step instructions here on how to do substitution. We're just going to go through it together, but if you want to read them, you're more than welcome. So we'll go right down to class example 1, right there. It says, consider the following system of equations. I know it's a system of equations because there's two things here, right? I'm going to call this one 1, equation 1. What is that? Did you guys see that? And this is equation 2. This is crazy. All right, so we got equation 1, equation 2. That's a system of equations because it's more than one line at a time. The first step to solving with substitution and knowing when solving a substitution might be really effective is that you have to have one letter in one equation completely by itself. It doesn't matter which letter. Okay, so you could get x by itself, y by itself, it doesn't matter. As long as you have one letter in one of the equations completely by itself. If you look, neither of these equations have that. Right? The first equation, the x's and the y's are both on the left side. The second equation, x's and y's are both on the left side. So neither one is set up nicely for substitution. If they're not set up nicely for substitution, you make one of them set up nicely for substitution. We're going to take equation 1, the purple one, and we are going to change it so that x is by itself. So we have x plus 4y equals 17. That's true. The red circle is freaking me out. If you wanted to get x by itself, you need to move the y's to the other side of the equal sign. To do that, I subtract 4y from both sides. That cancels out on the left. And now I have x equals 17 minus 4y. Like that. I have one letter isolated by itself. That's the first step. Sometimes it naturally happens. Like the question already has it set up for you, which is wonderful when that happens. Sometimes it's not. So we manipulate one of the equations so it is. Awesome. B says, I'm going to ignore B. I'm going to show you my next step. Okay. So the reason getting one of the letters is beneficial is that in a system of equations, we're trying to figure out where x is the same in both lines and y is the same in both lines, right? Like the same point. That means if this x equals 17 minus 4y, then this x in the other equation should also equal 17 minus 4y. What we do is we take this value, We say x equals 17 minus 4y, and we substitute it in to our second equation. We're going to go to that second equation. We're going to change x to be this entire thing. I'm just going to scroll down and see if I have the space to do that. I'm just going to keep working from here because I'm going to run out of space because I show a lot of steps. So on the second equation, I now have 2. Instead of x, I have 17 minus 4y. And I substitute with brackets. Then I have minus y equals 7. I tried to color code it. So all the blue is stuff that was originally in the second equation. The purple is what I substituted from the first equation into the second equation. The brackets are very important. So when you substitute, please make sure you put brackets. Awesome. Here's how you can tell if you did substitution properly. You've done substitution properly if there's only one type of letter left. The only letter remaining is y, right? I have 2 of them, but there's only y's remaining. There's no x's, z's, a's, b's, there's nothing. Just numbers and the letter y. That means I've substituted properly. The reason that's beneficial for us is we could now take this equation and get y by itself, and then we would know our y coordinate to our system of equations. To figure out that y coordinate, after you substitute, the first step is always expand. All right? So if there's any multiplication that needs to happen, you need to do that. For us, it's this 2. The 2 expands into the brackets. When I multiply that 2 in, I now have 34 minus 8y minus y equals 7. After you expand, we always collect like terms, right? Things that are the same that can be combined. If you're looking, I have negative 8y and I have negative y. Those can combine to become negative 9y. Once you've expanded and collected like terms, you now need to try to isolate y. Get y all by itself. To do that, you move things away from the y, starting with anything that's been added or subtracted. I have this plus 34 out here. I need to subtract 34 from both sides. After I subtract 34 from both sides, I have negative 9y. Make sure you still have it as a negative 9y equals negative 27. A lot of people lose that negative sign on the 9. That is with the 9, right? So it's still with it here. Once I've moved any additions or subtractions over, I need to move any multiplications or divisions over. I have negative 9y, that means negative 9 times y. The opposite of timesing is dividing. My final answer for y is y equals 3. Awesome. The goal was to figure out where 2 lines cross each other. When we talk about where 2 lines cross each other, we're talking about an x-coordinate and a y-coordinate. Currently, we've only solved for the y-coordinate. You now need to figure out what the x-coordinate is. I like substitution because finding the second coordinate is always pretty easy. The reason it's easy is you can take your answer for y, and you can substitute it back into that first thing that you substituted with. And you'll notice that x is already by itself in that equation, which is why it's so handy. It's like one big loop. When I substitute 3 back into this equation, I now have x equals 17 minus 4, and instead of y, I have 3. To figure what the x-coordinate is, you calculate this. You end up getting x equals 5. These two lines cross each other at x equals 5, y equals 3. That would be my solution. There's a lot of steps to substitution. You're going to want to practice a lot. Right? I think I've said that a lot this year. But you do. You definitely want to practice this method. Same with elimination. You get a lot of practice in. So that way you get used to all of the steps. So there's a lot of them. Awesome. Part C. Verify that the solution satisfies both equations. When you see verify, that means make sure that this input actually gets that output, right? These need to be actual numbers that work in your equation. To verify, you take the original equation. I can't quite see the original equations anymore. These guys right here. And you change x to be 5, and you change y to be 3. When you do that, it should look like this. So I'm changing the first equation, x to be 5, so it's x, plus 4 times y, that's 4 times 3, equals 17. If my solution actually works, then when I calculate this, it should equal 17. If you put that in your calculator, you end up with 17 equals 17. I have now verified that the first equation works. You should also verify that the second equation works. All right, so you go to the second equation, you do the exact same thing. You change x to be 5, y to be 3. So I'm going to have 2 times 5, and then minus 3 equals 7. It looks like this. Whoa, sorry. 2 times x, which is 5, minus y, which is 3. And according to our equation, it should equal 7. If you put that in your calculator, you end up getting 7 equals 7. That means that that x and y value is a part of that line that verifies my solution. You need to do it for both equations if you get asked to verify something. That's substitution. A little crazy. You can see why people probably like graphing more, right? So if you just get y by itself, you can graph, and it's pretty easy. On a multiple choice test, if you're really good at graphing and really good at getting y by itself, heck, you could graph every single question, and I would not blame you. However, if a question asks you, and it's a written response, to algebraically do elimination or substitution, you must do it the way it asks you to do it. Okay, that's where you get your marks. Awesome. Let's do, I think there's a couple more. We'll do class example number 2. Solve and verify the system using the method of substitution. We're just going to solve it. We're probably not going to verify it. It kind of takes a lot of time. You can practice verifying on your own. Looking at these two equations, I like to label them equation 1 and equation 2 so that I know what I'm talking about. This is equation 1. I'm going to call this guy equation 2. The first thing you need is one of your letters by itself on one of your equations. And it doesn't matter which letter and it doesn't matter which equation. So whichever one's easier to get by itself, do that one. For me, looking at this, the first equation, I don't have x's or y's by itself. Second equation, I don't have x's or y's by itself. So I can pick either one and get either letter by itself, and I'll still be right. I'm going to pick the first equation. I'm going to take 4x plus 3y equals 0. And I'm going to choose to get x by itself. To get x by itself, I need to move over any additions. So I subtract 3y from both sides. That cancels out, and I now have 4x equals negative 3y. I then have to get rid of that 4. I get rid of that 4 by dividing by 4. That's a 4. You would never know. It'll cancel it on that side, and I'm now left with x equals negative 3 over 4. First step, get one of the letters by itself in one of the equations. I've accomplished that. I got one letter by itself in one of the equations. I then take that letter and I switch it in to my other equation. It has to go to the other equation. You can't switch it back into the same equation. So if this came from equation 1, I have to switch this into equation 2. That means I rewrite equation 2 now, but instead of x, I go bracket negative 3 over 4 y, and then close the bracket. Everything else in that equation stays the same. Minus 9y equals y. We got a letter by itself. We substituted it into the other equation. I've done a good job because I only have one letter left, y. After I substitute, I must expand. Expanding this one's a little tricky. So when I multiply this 8 into the brackets, you go 8 times negative 3 and then divide it by 4. You should end up getting negative 6y. Okay, so that's 8 times negative 3 divided by 4. Everything else stayed the same. So I expanded, and I got that. Anytime I expand, I try to collect like terms. Like terms are same letters, right? I do have two things that are the same letter on the same side. I have a negative 6y and a negative 9y. Those can combine to be negative 15y equals 5. My last step is going to be to get y by itself, so I divide by negative 15. When I do that, I get my y value. Y equals negative 1 over 3. If you put that in your calculator, you went 5 divided by negative 15, you would have got negative 0.33333333. You want to go math, frac, and then we've practiced a lot on our calculator. So you get the lowest terms fraction. My y value is negative 1 over 3. Awesome. Unwritten response questions in particular. These questions can sometimes be painful to mark because people do all that wonderful work and then they stop and they're like, yep, that's my answer. And they forget that every answer should have a y value and an x value. You should always get 2 values. You only have 1 right now. To get the second one, you take your solution and you substitute it back into the first equation. Right? It's like one big loop. When I do that, I don't have much space, so I'm going to have to go back to the right side. I now have x equals negative 3 over 4. And instead of y, I put my answer for y, negative 1 over 3. You then need to multiply those two fractions together. To do that in your calculator, make sure you put brackets around your fractions. Okay, so I would put brackets around my negative 3 divided by 4. So I go bracket, negative 3 divided by 4, bracket. That tells my calculator this is a fraction. Then I go times, bracket, negative 1 divided by 3, close the bracket. When you do that, you're going to get 0.25. If you turn that into a fraction, go math frac, you get x equals 1 over 4. My solution is at 1 over 4, comma, negative 1 over 3. That's my input and my output that works for both lines. That question's a little bit trickier because it's got fractions involved, right? So that makes it a little bit more challenging. Awesome. We'll look at example 3. I think that's going to be our last. Yeah, we won't do the other one. So we'll stop there. We'll do one more. This one is hard because step 1 is really hard on this question. All right, it says, consider the following system of equations. Solve the system using the method of substitution. I know this is a system of equations because I have 2 equations. I'm trying to figure out where they cross each other. I'm going to use substitution to figure out where they cross each other. Step 1. Get one of the letters by itself. That's hard in this question. The reason that's hard in this question is because you have all these brackets and stuff. The brackets just make things a little bit more challenging. What I'm going to do when I get a question like that is I'm going to expand and collect like terms on both equations before I even start the question. That way I'm going to take this, I'm going to turn it into something I'm used to seeing, like the question before. So for equation 1, I'm going to take that 5, I'm going to expand by multiplying it into the brackets. When I do that, I now have 10a minus 15 plus b equals 5. And now that looks like a question I'm used to seeing, right? I don't have all those brackets kind of muddying the waters. I would collect like terms, but I have no like terms to collect on the left side. They're all different. A's, no note letter, and B's are all different. On equation 2, I'm going to do the same thing. I'm going to expand this -2 into the bracket. It's been a while since we've multiplied things like that. Remember, it's a -2 coming into the bracket, so the negative goes with it. This equation now becomes 6a minus 2b plus 8 equals 20. Now we have questions we're used to seeing. Right? So we expanded, so we had questions that were kind of normal to us. Now I move on to step 1. Step 1 is get one of the letters by itself in one of the equations. There is an easier route for this question. The easier route would be equation 1, the blue one, and getting b by itself. The reason why that would be the easiest thing to get by itself is because this b has no coefficient. There's no number in front of it. If you look, all the other letters have a number in front of it, meaning that they're all going to require a couple extra steps to get by themselves. This equation had b with no coefficient, so it's a little bit easier. Again, if you picked a different letter, it doesn't matter. Like, you're not wrong. Okay, let's start with equation 1. I'm going to add 15 to both sides, plus 15 to move that to the other side. And I'm going to start writing on the left over here, just because I need the space. That gives me 10a plus b equals 20. The next thing I need to move to the other side is the 10a. It's a positive 10a, so I subtract 10a from both sides. I now have b equals 20 minus 10. Fantastic. First step, get one of the letters by itself. Done. Second step, take that and substitute it into the other equation. So I'm going to take this from equation 1, I'm going to substitute it into equation 2 for b. If this b equals 20 minus 10a, then the purple b should also equal 20 minus 10a. That's called substituting. When I do that, I now have 6a minus 2 bracket 20 minus 10a bracket plus 8 equals 20. Sorry, the 10a kind of got dragged across. That's my substitution step. That's why this is called substitution. And that's why they named it what they named it. After I substitute, what do I always do? Put the numbers into the brackets. We expand, right? We multiply. So for us, we're going to take the -2 and we're going to multiply it into the brackets. When I do that, that gives me 6a. Minus 2 times 20 is minus 40. -2 times -10a is now plus 20a. The plus 8 is still sitting over here. And the 20 is on the other side. Anytime after I multiply, I collect like terms. So if there's anything that can be combined, we want to combine it. In our case, we have 6a and 20a. Those can combine. And we also have -40 and plus 8. Those can combine. My new equation would be 26a minus 32 equals 20. 6a plus 20 is 26a. Negative 40 plus 8 is negative 32. We substituted, we expanded, we collected like terms. You now are set up with only one letter. You need to get that one letter by itself. So we need to get a by itself. To do that, we have to move this 32. So we plus 32 to both sides. We get 26a equals 52. And my final step is divide both sides by 26. That means a equals 2. Yep, for sure. Remember, every answer should have two values, right? An x and a y. In this case, an a and a b. You only have the a value. You then use your a value in the first equation to figure out the b value. I take this and substitute it back into this. Back into equation 1, where I now have b equals 20 minus 10 times a, which is 2. You throw that thing in your calculator, you get b equals 0. My solution is a equals 2, b equals 0. Those are the two values that would work in both equations. If you feel like challenging yourself, there's a question below where instead of the system of equations being 2 lines, it's actually a system of equations being 3 lines. And all 3 lines cross each other at one point. It's a little tricky. You're going to have to do substitution a couple times. We're not going to do it as a group. It's purely just for somebody if they want to try to have some fun and really challenge themselves. Everybody else, I would like you to move on to the assignment part of the booklet. So these questions, it starts off easy. It will get harder. Okay, so try to work along until you start to get kind of stuck. Yeah, for sure.